Determine the equation of the inverse function f inverse x for f of x equals the square root of x minus 2 for x is greater than or equal to 2. All right, so to do any inverse, the process is to first swap your x and y values and then resolve the equation for y. So the y value here is kind of hidden, but f of x is equal to y. That's how we define graphs. So we can just switch back to the y, that's fine. You don't really need to pay a whole lot of attention at this point to the x is greater than or equal to 2 part. I'll show you what to do with that in just a moment. So for right now, we have a square root function, and the next step in the process is to swap our x and our y values. So the x I'm going to move over here, y I'm going to move over here, and it will look like x equals the square root of, oops, I meant to go back to the other color, x equals the square root of y minus 2. So all I've done is just swap the x and the y positions. All right, so now that I've done that, I need to resolve the equation for y. So I got to get y by itself. So the first thing I need to do is get rid of that square root. So let's square both sides of the equation. So x squared equals y minus 2. Now y is almost by itself, but not quite. I need to next add 2 to both sides. So x squared plus 2 is equal to y. And that's getting me well on my track here to defining the inverse. So this would be x squared plus 2. Now, this x is greater than or equal to 2 part, so this is where this is going to come into play. If you look at the graph of the original function, so it was a square root that is shifted to the right by 2 units. All right, so it would look something like this. Now, if we invert that, what happens is you're always flipping the graph about the line y equals x. So this point here at 2, 0 would flip and go to 0, 2. The same for all the other points, and we're going to end up with a graph that looks like this, which is close to what we have, except our graph actually has this part as well, because x squared plus 2 is a parabola, the full parabola. In order to make this perfectly right, what we would then need to do is make sure we restrict the domain to where this is greater than or equal to 0, so that we have the correct part of that graph.